Alright, time for another DraftPhysics.com video presentation. Debate physics also. But again, the debate isn't any kind of decent form, frankly. They don't want to debate the actual physics. They want to debate something about personalities or something. So anyway, the physicist Michael, right, who engaged in the conversation, and we all know for no other reason than because the channel was kind of a low view channel at the moment, so we had nothing better to do. But physicists, generally speaking, don't answer any questions. I mean, they really don't answer any questions. They're actually interrogating their physics. So if you ask them, can you show me any evidence for this or that, they'll never do it. Again, they'll never show you it taking 4 times the fuel to go twice as fast. They'll just tell you it's the rule, it's the law, it's a fact, even though they don't have the evidence. So they're really the worst kind of shyster lawyers. They just fool the jury into thinking they have evidence when they really don't have any evidence. So anyway, again, I've offered thousands of dollars to have some of these people respond to these accusations that their physics really doesn't work in space. NASA doesn't use it because it won't land you on the moon. It doesn't work. And I just keep playing this denial game. So I've asked him things, things that are should be right in his ballpark, like the Eddington experiment. I've brought that up. And he has no response. He doesn't concede that, oh yeah, in 100 years they should have done this experiment successfully at least one time. And they certainly should have done it from space. It's ridiculous that their science hasn't in any way proven what they claim to be a fact. Alright, anyway, that's the simple accusation. He won't really respond to it and instead does this evasion and this distraction. So here we go with more of it. I really don't want to make this video. I really didn't want to make this video, but here's my response to you. So we're going to get to see a video. So this will be good. At least he knows how to do it, right? It's not beyond his capacity to directly respond. Now, will he directly respond to any of the physics arguments? I mean, pointing out 400, he's told us that springs don't conserve momentum. He's overtly said levers don't conserve momentum. Bold claims. Can he back them up with anything called a piece of evidence? Please note that this is primarily about the intellectual dishonesty, so whatever that even means. All right? I mean, obviously, I'm not going to be convinced by your accusation of intellectual dishonesty because, god damn it, I've been doing it for 10 years. All of the videos are public, thousands of videos. I haven't been doing this for any dishonest reason. I'm doing it because you people are a bunch of fakes and phonies preaching a religion. You're not doing science. You're preaching religion. Oh, fuck. About the methods that you're using. What's the fucking method? I say draw me a lever and show how it doesn't conserve momentum. That's a method? God, you people are so fucking dishonest. Anyone reading this, please don't use this as a jumping off point for sending insulting messages to DraftScience. Who the fuck would be reading this except people watching my videos? What the fuck are you even talking about? And they already think they have license to invade my personal life in all kinds of malicious ways. They're trying to censor me on, they don't want me to be able to make videos on YouTube. Because I talk my mind, I speak my mind. You're not allowed to do that, okay? And you just fucking placate that crap. You called a moron who makes shitty videos and you said he makes great demonstrations. That's demonstrations of what? Fake science. I mean, you're amazing. Amazing. Anyway, or even spread this link around. I'm posting it here on DraftScience video and leaving it unlisted because this is not the sort of thing I want my channel to be about. So again, exactly, you don't want your channel to be about anything real. You're just a preacher. You want to just make records of you preaching your preachy crap, and you don't want anybody standing up and saying, what about evolution? You don't want to hear it. Plain and simple. You don't care that you're living a lie. And that's what you're doing. And you're preaching a lie. So let's see if he stays on the subject of physics. So the last comment I made, I pointed out how, if I reverse your experiment, let's show it on the board. If I reverse it, right? You're making the claim, and this is his actual claim, so there's no doubt about the claim he's making. I guess that could be bigger. So he's basically making the claim that the same spring compression can create different varieties of momentums, depending on the weight I put on. So the heavier the weight, the more momentum I'll create. And if I just reverse that experiment and say, well, okay, I'll take something, a heavy mass with 400 momentum, and I'll smash it into the spring. He's saying it's going to weigh. That is, springs weigh things. You know, springs are a scale. They're weighing something. I'm saying, how much does it weigh? I put the scale here, right? And we do the experiment. He's saying something with 400 momentum is going to weigh the same exact amount as the 2. He's saying 10 pounds weighs 5 pounds. That's what his video proved, okay? He proved it. And this is in the same experiment where he did the famous professor, right? The same series of experiments, the same tools, the same instruments, where he did the Professor Lewin magic momentum experiment. You know, where you put the one mass into the two mass, you get 2/3 the velocity, which ends up being 133, 33% more momentum, 33% free momentum. You went in with 100, you leave with 133 in this direction. The universe has 133 going that way. Nonsensical as hell. He won't even concede that, gee, that sure doesn't sound quite right, does it? Something's going this way, I make it 133, then I can make it 175, and then I can make it 250. I can just increasing it by banging into heavier and heavier things. I can just keep making more and more free momentum. All right. So let's play the video. All right, so that's a little bigger than it needs to be. Yeah. All right. So let's see what we get here.
So this video is going to be a little bit different. Here I'm going to respond directly to DraftScience's claims that he's been making in a number of different videos and putting in comments and things like that. Before getting into the details, I want to mention...
Thank you. This is exactly what somebody should be capable of doing. In 2 years of all these critics, not one of them has been capable of actually, well, we don't know if you're going to do it yet. I mean, actually showing my argument and then countering it. So hopefully you're going to show my argument and then counter it.
Mention that, again, directly to DraftScience, I am planning on making that lever setup that you really seem to want to see. You've talked about how you've been asking people to do this for 2 years. So
yes, I want you to prove that levers don't conserve momentum. That's what you have to do to save your theory. You have to prove that levers don't conserve momentum, which I don't think you're going to be able to do it. Okay, so good luck with that.
I am trying to set that up. But what I really don't want to have happen is for me to go through the time and effort of building the setup, doing the experiments, and getting some results, and then end up having you dismissing some of my results.
Yeah, for reasons, okay? I just dismissed, okay, a guy just posted a video, said proving kinetic energy. And instead of dropping something from 4 times the height, he dropped it from 5 times the height. So it doesn't matter what kind of mistakes you make, I can't criticize. Is that what you're saying? Well, I'm saying, look, I don't really have any desire to do that, but I'm just saying, what exactly is our job? As if you were to be an investigator or a detective, what are you basically saying? It's, don't sit there and get into the facts. No, they're not really important. I mean, a scientist is a detective. You can't say, oh, turn off your detective. Don't debunk the magician. Just go along. He pulled the rabbit out of his... Oh, yeah, he pulled the rhinoceros. Bullwinkle pulled the rhinoceros out of his hat. So should I go with that?
Because they, in case they don't match your position. So what I want to do is I'm going to set up a line.
It's not that it doesn't match my position. I'm just arguing that how does your experiment work mechanically if it can't be reversed and get the same results? If I can't reverse your experiment and produce the same outcome, it's clear there's got to be something wrong with it.
live stream on the morning of Saturday, July 28th, so that you, and again, I invite your viewers or anyone else.
This is great, fantastic. And yeah, I'll just point out, let's use a pendulum, because if we keep it horizontal rather than vertical, then we don't have to worry about gravity's influence. All we're getting from gravity is the velocity. So we could use pendulums to produce the velocity. It'd be really great if you had a little time detector to figure out that the velocities were exactly what they're supposed to be at the bottom of the swing. And, you know, so lots of ways this is really simple. Really simple experiment. And again, you should be able to concede that it seems ludicrous that in 350 years, nobody's inquired, nobody thought it might be a good idea to actually prove that this theory is real. And you can prove it in this simple way.
To hold similar positions to you, to join that so I can get feedback on my proposed design for this particular experiment. So if there's any details that you think are inaccurate or I seem to be missing, you can point those out.
This would be great, right? It'd be great if this is what happened 2 years ago. If this is what happened 10 years ago when I started talking about the two slit and all these other experiments. But this is, you know, so this is great. Fantastic.
Before I actually do the data acquisition. So if you're interested in taking part, please let me know and I'll set it up maybe as a Zoom session so we can directly talk with each other without having be these, you know, back and forth responses where I think a lot of times we might be talking past each other. Okay, so on to the main thing. You asked me, what is dishonest about anything that you've said? And I hold by that position that I have said that you are being intellectually dishonest in how you are approaching.
I don't even know what this intellectual qualifier means. I'm not the one using jargon. I'm not the one hiding behind convoluted mathematics. So, I mean, I say it's intellectually dishonest for you to sit there and imply that Newton endorsed 1/2 mv squared when he directly opposed it, when it's obnoxious to his entire understanding of motion in the universe. Galileo, Descartes, and Newton believed in momentum. They believed it was energy, and you are implying that their theories are consistent with this Leibnizian religion of the living force. That's intellectual dishonesty. When you don't point out that Newton directly opposed this theory. He directly opposed your derivatives of F equals ma. F equals ma was not Newton's formula. You're shoving that crap in his mouth, and that's intellectual dishonesty.
These questions, and that's a strong claim, so I should be able to back up my claim with evidence. So I want to start by explaining the disagreement between us as I see it. I really don't want to strawman you, so if there's any error in how I'm presenting your position, please let me.
I don't even know how there could be any confusion. I'm defending physics the day Newton, okay, let's say 1678. That's when physics stopped being physics. Okay, all the good physics is now done, and now you're just going to screw it up. You had all the right answers, and then you decided to believe in a bunch of religion.
No. So we each have a model for how we think momentum and energy works. Okay? So in your model, again, please.
Momentum is energy. There's no other such thing. There's just movement of physical objects in the universe. Things that have mass, they move, they hit something else. This is not complicated.
Correct me if I have anything wrong here. I think these are all statements that you've repeatedly made. So hopefully this is an accurate representation of your model of how you think momentum.
Mine, Descartes, and Galileo's, and Newton's. Yes, it's a mechanical universe. Descartes basically said, look, you push it, you start it moving, and the mass, the movement just moves from place to 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 place. That's it. The movement is eternal. Things just possess it. Something can possess the movement, then it bangs into something else, and something else possesses the movement, then it bangs into something else, and something else possesses the movement. The quantity of motion just migrates through the world. Period. Not complicated.
energy works. But if I'm wrong, please correct me. In your model, momentum is always conserved no matter what. Momentum does not care about direction. So you've said multiple times, if I have 200 kilogram meter per second units of momentum in one direction and 200 kilogram meters per second units in the other direction, that adds up to 400. Okay, so momentum does...
It's just like an explosion. Yeah, so we know when it's an explosion, that's exactly how we would measure it. We wouldn't say that explosion canceled out and there's no explosion. Everybody would agree there's stuff flying. There's little pieces of shrapnel going that way and little pieces of shrapnel going that way, and none of the shrapnel cancels. It's all real energy in the universe. You have to add it all up. You add up every little piece of shrapnel and then you put the bomb back together. Yeah.
Not care about direction in your model. You've talked about how springs and fuel sources store momentum, which depends on, again, mass times velocity.
They're storing the equivalent. That's what force is. I mean, why is this complicated? Force is the little tiny stuff like photons, okay, and other kinds of discrete speed of light type radiation. I could say magnetism, I could say gravity. Those are forces, okay? Forces behave a little different, but it's exactly equivalent to momentum. So exactly as Newton stated, you want to go twice as fast, twice the force. You want to go 3 times the speed, you add 3 times the force. They are equivalent. They are the same damn thing. Okay, so yes, when the physical body thing hits something else, it converts the energy into something inside of this. The momentum is converted into the spring's tension, the magnetic tension between the atoms, however you want to look at it. It turns it into ions in the battery. It does different things, but the energy is still there because all of that stress against the atoms is equal to the momentum. So you can get it all back. They're storage devices. For fuck's sake. They're storing the force. Okay, but it's equivalent to momentum, so it doesn't matter what form it is in, whether it's because two atoms are polarized oppositely and they're attracting, or 2 atoms are polarized the same and therefore repelling. It doesn't matter what form the force is in, it's just pressure. The pressure ends up being caught in a trap, and you can let it loose.
Instead of directly relating to how much kinetic energy, 1/2 mv squared, how much kinetic energy they're able to give.
Yeah, I'm saying there's no such thing as whatever that is, 1/2 mv squared, or as it originally started, mv squared. There's no mv squared. It's completely screwing up something very logical about the Galilean system, which is, as you're going faster, you're in the gravity less time. And it's really about how much time you're in gravity decides how much force you either how much force pushes you or how much force you have to push against. It's just about time. It's 9.8 meters per 1 second. I've said that repeatedly in videos you've probably heard.
To objects, okay? So that is, I think these are accurate. There are other things that we can kind of go into detail with specific applications of this to springs and levers and things like that. But I think I think you would agree with those points. Okay, correct me if I'm wrong. My model, and I shouldn't say my model, this is the generally accepted scientific method. I don't think you would disagree that it's in most...
I would disagree in the sense that your model, your science contradicts itself. Professor Lewin says right to my face, nature can play with kinetic energy, but nature can't finagle momentum. And then 5 minutes later, he's doing an experiment where he's creating free momentum in a direction. I mean, your physics is double forked tongue. I mean, forked tongue all over the place. You talk with 2 faces. What's the point of saying conservation of momentum means something when you're going to sit there and tell me that springs don't conserve it, and levers don't conserve it, and gears don't conserve it, and hydraulics don't conserve it? Nothing, no tool known to man conserves momentum. Because if they do, they're going to create free kinetic energy. That's the simple truth. Again, it is just a physical fact. Why can't you just respond to the statement? It's a physical fact that if you're actually capable of getting the energy from one mass into some other different mass, anytime you can move the energy completely from one thing into another thing of a different mass, you have to destroy either momentum or kinetic energy. They both can't be right because they give completely different answers to how much energy is in the object. The theories are incompatible. You have to pick one. And frankly, it's obvious which one has all the historical data on its side, and it's momentum. Again, you have no physical evidence of it taking 4 times the fuel to do any doubling of the speed.
Most physics classrooms, this is what is taught. So in the model of momentum and energy that I think is accurate, total momentum is only conserved when there are no external forces, when we just have...
None of these experiments have any external forces in them, so this is just a dodge. You talk about intellectual dishonesty, this is intellectually dishonest. None of these, this experiment where you made this extra momentum doesn't have any external forces. There's no excuse for you not conserving the momentum between one experiment and the next. You got different total momentum numbers. There's no external forces here. Okay, there's just this fact that you put a 2 mass instead of a 1 mass. It's just such a dodge.
Objects interacting with each other, and there's nothing outside of that system that we were looking at that is...
I mean, these are such simple experiments. We're just saying, look, you got a 10-ton train going 5 miles an hour. You put a 5-ton train 2 distances on the lever. What happens when you plow the 10-ton train going 5 into the lever? It makes the 5-ton train go twice the speed. The end. The conversation should be over. I told you of the experiment that's been already done. Okay, you plow the 2 mass. Okay, with the half velocity against the 1 mass with the twice the velocity. So you have this 2-to-1 relationship in the kinetic energy. Yes, they have exactly the same momentum, but one of them has twice as much energy. What happens when they collide? Does the collision move in the direction with the thing twice as much of energy? No, the collision stays dead right there in the center, indicating momentum rules, kinetic energy rules.
Adding additional forces. In my model, momentum is also a vector. If I have an object with a certain momentum in that direction and an object with an equal magnitude momentum in the other direction, the momentum of that system will just add up to...
Yes, if I have it inside a basketball, yeah, they'll cancel because it'll go this way and then it'll go that way. It'll really do those things, though. It doesn't cancel by some magic trick. It cancels because you turned left and then you turned right. They're actual motions that you have to actually consume the energy. You can't just pretend it away. It doesn't just not exist. It's actual real stuff. And if you shoot it outside your ship, it's going to do real things. I shoot a bullet that way and I shoot a bullet that way out of a zip gun. Nobody's going to say, 2 bullets. Nobody's going to say I didn't shoot a bullet and I didn't put bullet into the environment. Of course I did. I put 2 of them into the environment. They didn't cancel.
0 if those momentas cancel out. And again, the classical picture of energy is essential for understanding springs, fuel sources, so kinetic energy is 1/2 mv squared, and again, there's many other kinds of energy that we can keep track of.
Says you, right. So I'm saying that weight, heat, momentum, we can go through pressure, let's see, what else is there? There's a few more. It's all the same thing. F equals E equals every single one of them. They're all the same stuff. There is no different thing that makes work. Work is a category of energy. Heat is a category of energy. If you do work and you do heat and you do this and you do that, it all adds up and it's this much energy. It's all equal.
Okay. So we each have a model, and we want to determine whose model, if either one of these, is consistent with reality. Okay. So how do we do that? if we're just
You're showing it takes 4 times the fuel to go twice as fast. Show me a car that does that. Show me. That's how you do it. And in 350 years, you've got nothing. If you roll a ball on the floor, I'll explain why the ball rolls 4 times the distance when it's going twice as fast. So I'll explain that. That's all about friction. So show me some other example. So show me a frickin' experiment on this planet somewhere that you have done that explicitly shows you pouring 4 times the fuel in, because you're not going to show NASA doing that. NASA's saving fuel by getting into space as quickly as possible. It gets more and more efficient at getting to a height the higher it shoots for. The higher it shoots for, the less it spends per mile. That's the truth.
Screaming at each other, that's not going to be a good way to determine whose model is right, because
Who cares? All right, but let's just say, it's not screaming at each other, frankly. It really isn't screaming. Okay? It's not all that hysterical. But the fact is we are flinging some insulting words. There's a point where I'm going to say, yes, you're deliberately being dishonest because you're evading every one of my arguments. I've made a simple argument here. If I reverse your experiment, it can't possibly compress the spring the same amount. 200 momentums will not compress the spring the same as 400 momentums. It's not reversible. Therefore, it has a physical problem that you have to explain, because it should be reversible.
you'll say, oh, it should do this, and that should be what the outcome of the that should be what happens. And I would just yell, no, this is what should happen in reality. So the only way to differentiate which of us is actually right, again, we could both be wrong, but we can't both be right. These are contrary positions. This is where experiments come in.
Yeah, this is really funny. That after 300 years of preaching something, you're saying we have to do the experiments because they haven't already been done. That's part of the argument here. You can't see how ludicrous it is. I mean, do I really have to do the Eddington experiment? Right? Your physics has all the technology. Your physics owns all the satellites in space. Your physics owns all these, very expensive $10 billion telescopes. My physics doesn't have any of those resources, and your physics won't devote it to the simple experiment. 400 times better resolution. You don't need an eclipse. And it takes 5 minutes, and yet you haven't done it. Those are real points against your side that you should at least acknowledge. You have dropped the ball. Your science has fundamentally dropped its responsibility ball. It has a responsibility to prove and shore up what it claims, and it hasn't done any of that when it comes to 1/2 mv squared. Hasn't done anything. Since 1740, it hasn't done anything. I mean, it did some fake clay experiments in 1740. Since then, it's done nothing.
Taking data and actually looking at the results of experiments in reality. So I'm going to focus on the spring launching the masses experiment that I did. This was the one where I had the two carts and the spring in between them, and that spring would launch.
This is fantastic. Okay, will he actually, now let's see if he will actually address my very simple argument that I've made 6 times now. 6 times in video, I have pointed out what's wrong with that experiment. It's not about, oh, it's 200 this way and it's 200 that way. That's the same. It conserved the momentum. No, it's about the fact that you use the same spring compression and you made more momentum. You can't do that.
Two masses in two different directions, and that was kind of the basis of the experiment. So I did the experiment, and we each had a prediction for what would happen with the experiment. So for this...
It's kind of funny, right? Obviously, I'm predicting that, yes, these go away with the equal because they're equal masses. So we agree on that part. The prediction is that you can't make this difference in momentum. That can't happen. Reverse your experiment and explain to me how 10 pounds weighs 5 pounds. Because that's what you're really saying. Springs measure weight. So go ahead, explain how 400 equals 200.
Spring launching prediction, your model was that the launch velocity ratio should depend on 1 over the ratio of masses. So if I double the mass of the object, it should only be launching off of that system with half the speed. If I were to triple the mass,
I'm telling you, yes, and I've given you this rational argument that that's how the springs conserve momentum. You're saying springs don't conserve momentum. Then what the fuck is Professor Lewin talking about? Why does he bother saying nature can't finagle momentum when you're overtly telling me that springs can give me any kind of momentum I want? I just put a different weight on and I get a different momentum. Come on. It's weight. You can't make different weights.
it would be 1/3 the speed. Okay, that was the prediction of your model. Okay? Whereas mine, using conservation of energy, says that, well, that spring stores a certain amount of energy, and when it launches the two objects, that energy is going to be split in some way between the two carts, not necessarily evenly.
Well, it isn't necessarily evenly in the cases where you did the experiment. So why are you talking this crap now? You did the experiment with 100 and 100 or 200 and 200. You didn't do the experiment with uneven masses. Come on.
But the launch velocities, the launch velocity ratio should depend on 1 over the square root of the mass ratio. Okay? So we have two different models, and I did this experiment. So the idea is the experiment is supposed to differentiate between which of our models is able to make correct predictions.
So there's just no point. Again, his overt experimental result is he's saying 400 momentums weighs the same as 200 momentums. Those two things will compress a spring the same amount. You can't possibly say that with a straight face. So if what do I call this except some sort of gross dishonesty? Do I have to really believe that you can't understand that momentum is essentially a weight and that you can't compress a spring with twice as much momentum the same amount? That it's impossible to compress a spring with twice as much momentum the same amount as 200? 400 cannot possibly compress a spring with only 200? Damn. And vice versa, of course. Obviously, the 200 weight cannot weigh 400.
Or at least narrow.
These two objects, I'll show them. I mean, come on. How can it, look, I know this is subtle, all right, so, you have to get up to speed and understand the argument, but look, he's basically, let me turn this board up. He's saying that something that's 400 pounds is going to weigh the same as something that's 200 pounds, that he's going to get the same spring compression, because the same spring compression was in both experiments. So he has to resolve that somehow the same spring compression, if I reverse the experiment, is somehow going to be created by these two differential weights, that 5 pounds will weigh 10 pounds, or that 10 pounds will weigh 5 pounds. That can't be a reasonable statement. What do I call that? I mean, let's not call it insane, but what is that? I mean, it's so completely wrong.
Go down, say, well, this one, its prediction didn't match, so that idea is definitely out. Okay? Again, in science, we can't absolutely verify anything. We can only falsify ideas. So
this is in the context where he conceded that the sensors that are doing his velocity are a little buggy. They sometimes don't see right because they're facing each other and interfering with each other. So he already conceded that maybe his velocity readings aren't perfect. He has no secondary way to measure the velocity. He didn't show us he didn't give us the original video clip so we could look at the frame rates and see if those velocities were actually correct. But obviously my accusation is that you don't have the right velocities, because there's no way the same spring compression can do this. There's no way I can reverse your experiment and produce it back to its original condition. 400 pounds will not weigh 200 pounds.
I did the experiment, and as you admit, at the I have a couple of timestamps on here that I want to mention. So at 4 minutes and around 37 seconds, you admit that the data supports my model and.
No, this is too idiotic. I'm clearly accusing your data of being shit. Your data is wrong because it's not physically possible. So look, it's exactly the same drawing, for fuck's sake. I mean, it's so ironic. I mean, it's the same fucking drawing on the board that I just have right now. I mean, come on. He's heard the argument, and here he is playing this game. That look, I have the little explosion right down here. I drew a little explosion, to boom, and point out how I can't make the explosion make more or less energy. It can only make so much energy. That's what it makes. A certain number of little particles fly off of the explosion. It only makes one kind of momentum. It cannot make differential momentums. Fuck. And clearly, if I reverse it, your numbers are saying that in one explosion I have 400 pressure, in the next explosion I have 200 pressure. Well, if I push the 400 into a stick of dynamite, it's going to be a more powerful stick of dynamite. There's more pressure. I mean, damn it, you can't understand this argument? Damn. Amazing.
Refutes yours, so let's watch that part.
Right. So the same spring compression in his experiment, that's explicitly how it came out, okay? I'm not lying or cheating. That's how his experiment came out. I mean, it's the only way he could make the argument that he did experiments where he conserved the kinetic energy from one experiment to the next. You got the same exact kinetic. It's the only way he can do it is to destroy the conservation of momentum. So just understand this just proves the two theories are completely incompatible. He had to destroy conservation of momentum to resurrect or erect a consistency in kinetic energy. You can't get the same kinetic energy without destroying the consistency of the momentum. Now, he's perfectly illustrating it, and again, I think it's well provable that momentum is weight. And all he's saying here is, I can make 5 pounds weigh 10 pounds without using a lever. It's energy out of the spring.
I got the same exact kinetic energy out of the spring. Okay. So the experiment.
So this is just ignoring my argument. He's just ignoring it. He's just pretending I'm not making this argument. You didn't get consistent momentums. You got more momentum out of the same spring compression. How many times do I have to say that? You didn't conserve the momentum. So just say those words. Say, yes, I'm perfectly comfortable not conserving the momentum because conservation of momentum is a bullshit idea. Say the words.
Outcome of the experiment matched with my predictions and did not match with your predictions. Okay? So
that's not the standard of a good experiment. So he's just basically saying any experiment that agrees with me is a good experiment. Any experiment that agrees with you is a bad experiment. Fuck. Oh, jeez.
You go on to say a number of other things, saying I changed the momentum of my system. Okay, saying I was adding momentum. And again, I
didn't say you added momentum. I'm saying, obviously, the same spring compression created more momentum. The two momentum numbers don't match. Put heavier things on the spring, I get more momentum. Put lighter things on, I get less momentum. That's what your experiment proved. Damn it. Could you try a little harder to accurately paraphrase what I'm saying, please? I didn't say you added anything. I'm arguing about the same spring compression didn't produce the same momentum from one experiment to the next.
It's your model. According to your model, that would be true. If your model were correct, I would be adding momentum and something would be wrong. In my model, well, the momentum is a vector. When these two...
So he's just ignoring the argument. We're not talking about in each experiment conserving the fucking momentum. We're talking about conserving the spring's compression. The two experiments have the same spring compression. You have to account for how the same spring compression, how many times do I have to say this? The same spring compression creates different momentums. You have to explain that. The same explosion made more explosion. You have to explain that. And you're just running the hell away, frankly. What is this? Okay, so you're going to pretend, oh, I really didn't get your point. Okay, so you had to say it 17 times because I really wasn't paying enough attention to hear your point. I'm comparing this experiment to this experiment. I'm not comparing that way to that way. I'm comparing this spring compression to the second spring compression. The two identical pressing of the springs you did on the cart. It's the same cart. You compressed it the same amount. And yet the two experiments produced two totally different momentums. I said this in text. I mean, how can he keep ignoring my point? And you have to call this ignoring, right? I mean, how many times do I have to say it? How many fucking times?
Two objects launch off of each other. They start with zero momentum. Nothing is moving. And when they launch off of each other, the magnitudes of those two moments.
So let's just all recognize that this is bullshit, right? This is the baby talk where they say, I'm lifting a weight and I lift it really, really slowly and I'm doing exactly the same work if I lift it fast. And if I hold it steady, I'm not doing any work at all. I mean, this is nonsense rhetoric, frankly. I mean, you talk about intellectual dishonesty. Oh, you can't get more intellectually dishonest than that kind of statement. And this is the same thing. Okay, we're talking about the explosive here. It's an explosive. It's not zero momentum. It's not zero energy. We already know it's in there. We already know what compressed the spring. You used force, you pushed the spring in. So let's not pretend we don't know that there's stored momentum there. It's clearly not zero momentum. It's stored energy. And you're going to release the stored energy. I mean, come on.
In those two directions match each other, so when I have a momentum in our positive direction and a momentum in the negative direction, those cancel out. You, in fact, agree with this, that my model, this was at the 842 part, so you agree with this, that under my model, I'm still getting conservation of momentum.
No, liar. Liar, 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 liar. I never agreed that there was any conservation of momentum. The two experiments are not the same momentum. I made it clear as fucking goddamn you can make it. I'm saying that clearly in these two experiments you have an illusion of energy here, but obviously it's an illusion because the spring can't make up its mind. 1 minute it's 5 pounds, 1 minute it's 10 pounds, then it's 20 pounds. It's any kind of weight you want. Somehow the magical spring produces whatever kind of amount of energy you want. The dynamite isn't a specific amount of joules of energy stored in it. No, it blows up in all kinds of different ways depending on what you put in front of it. I mean, it's a bullshit fucking answer. You're not getting to the frickin' point. Same spring compression, different total net momentums. I've said it in the words. I said net momentums. Damn it.
Watch that clip.
Conserve momentum in the sense he had the same. He argues he's conserving momentum because.
Let me back up just a moment.
I'm dismissing your experiment as shit without giving you an explanation. No, I provided the explanation that it doesn't make any sense. He conserved momentum in the sense he had the same. He argues he's conserving momentum because he had. So he's not going to play the whole clip, right? Because right here it shows 5 weight, 10 weight. Can't compress the spring the same amount. There's no way you can reverse this experiment and expect it to rationally compress the spring the same amount. 400 momentums will not compress the spring the same amount as 200 momentums. Can't be possible, can't be reversed. It is obviously a mistake. There's the same amount of motion going both ways in both experiments. But clearly it's the same spring in both experiments. This spring cannot produce these contrary amounts of momentum out. It can't.
According to your model.
According to Newton, Galileo, Descartes, yes. And I would think that I could poll people on the street and ask them, if I compress a spring a certain amount and then I decide to launch things with it, that, yeah, the lighter it is, the faster it's going to go. And the heavier it is, the slower it's going to go. And that the spring is going to produce a certain amount of push. And it's going to push heavy things slow and light things fast, but it's going to be the same amount of energy. Professor Lewin said, nature can't finagle momentum. You just finagled the fuck out of it. That's the simple truth. You just finagled the hell out of momentum.
The spring can't have two different
total explosions. It can't make two different amounts of force or pressure. It can only produce what was put into it. And that's all it has. And that's exactly what it gives back. What was put into it. It can't make 2 force or 1 force or 3 force or 7 force. No. It can just put out what was put in.
Magnitudes of momentum going out in those two cases. In my model, we're still getting conservation of energy. I'm not making anything up with...
Oh, he's still getting conservation of energy. We know that doesn't mean anything because it's conservation of kinetic energy. So say the word kinetic before you say energy to be at least polite here. All right, and I'll try to always say momentum instead of energy, or I'll say momentum energy. But let's just make it clear. You're not conserving the momentum. The law in physics is you have to conserve the momentum. Do I actually have to play for you? I've played the Professor Lewin clip probably 50 times. Nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. Those are his exact words.
Conservation of energy. In my model, conservation of energy both works. Conservation of momentum both works.
Okay, so fuck this. Fuck this. He's just ignoring the point that it's not the same momentum. Same spring compression, different momentums. And somehow that's conservation. Fuck. What can you say? It's just, he's just, what is the argument here? You really don't understand that 200 isn't conserving 400 and that 400 isn't conserving 200? That those numbers aren't evidence of conservation? They're exactly the opposite of conservation? Damn.
And conservation of energy works. So all of this, all of the data from that experiment is exactly consistent within, levels of, measurement error.
It's just amazing. It's a shit experiment. It's shit. It's fundamentally and catastrophically broken. And I have demonstrated it 6 times, and you're still defending it. When it's impossible. It's physically impossible. I can't duplicate it because there's no way I can do this violation of momentum. There's no way I can make the firecracker explode or not explode or use a pot and regulate it. No, I can't.
So all of the data is consistent with my model for momentum and energy and refutes yours. And let's look at what yours...
Okay, let's understand. And the data is easily understood as tainted. He conceded that his damn fucking thing that is actually recording the velocity is not reliable when they're facing each other. So he's already conceded a doubt. And he has no backup. No frame rate backup, no other system to detect actual velocities. So his experiment is completely critiquable as having vulnerabilities, and he's just doubling down on it. He's completely ignoring the argument and doubling down. Right here I have it, 5 equals 10. Play that part of the video where I'm explaining to you how 5 can't weigh 10, and that 10 can't weigh 5.
Response for this is. So this is around the 5-minute, 14-second period. So I'll go a little bit before so we make sure we don't miss anything.
So those are the results he got. Now, my simple argument is that's not possible. Springs can't do that. Okay, they basically feel weight. They're compressed by weight and they push with weight. So let's see what his counter argument is going to be to that. So you have 200 weight and 400 weight. The spring has produced, the same spring compression has pushed these different weights. You can't do that in reverse. It doesn't work. 400 pounds will not equal 200 pounds on the scale. The scale can't see them as the same thing. And that's what your spring has to do if your experiment's going to be credible. The spring has to restore to its original condition when I reverse your experiment. And there's no possible way 400 is going to weigh 200. And it can't make different momentums unless something breaks down in the function of the spring. Unless you've done something to screw it up in some way. And I'm not suggesting that's the case. I'm suggesting that the way he measures the velocity is what was broken. And therefore we got wrong velocity numbers, so it wasn't really these numbers. These numbers aren't any good.
So your response...
Yeah, that's my response. I've made 6 times. 6 times. That clearly your data is crap. That's what I've been arguing. It's crap. It's bullshit. I mean, that was probably the title of this video. BS. It's bullshit.
To this data is that that's not possible. Springs can't do that. And then you go off going through details of your model saying...
No, I quote Professor Lewin again. You have to conserve the momentum. Damn it. Conservation of weight. It's a real thing.
Springs can't make different momentas. Unless something so you're specifically saying, this is a quote, springs can't make different momenta unless something breaks down in the function of the spring, unless you've done something to screw it up in some way. And later say, I'm suggesting the way he measured the velocity is what was broken.
I can't make it any clearer. Yes, that's exactly the accusation. And so how do you recover from that accusation exactly? You just say, So let's see what he says. Jesus.
And then a little bit later, so it wasn't really these numbers. These numbers are no good. This is the dishonest part.
Oh,
this
fuck
is
you.
The intellectual.
God, that is so fucking amazing. Nobody can critique your shitty experiment. You claim the instruments aren't perfect, and then you say the experiment is. You don't see your duplicity in this bullshit? You have no backup way to measure the velocity. You have to rely on your radar detector, your ultrasonic, I guess, detector. And you're going to tell, and you admit that, hey, sometimes it's buggy. Amazing.
Actually bankrupt part. Your response to my experiment was that my experiment couldn't be right because it goes against what your model...
No, it goes against Professor Lewin's overt statement. Nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. Oh, God damn, he still thinks 400 momentums is the same as 200. That somehow the spring is okay, it's conserving the momentum. 200 is 400. 200 momentums is the same exact energy as 400 momentums. It's the same thing. Oh, damn it. I mean, again, what am I going to say? I'm just saying it. What is there to say here? I have to say it 6 times to a physics professor, at least a teacher. 6 times I have to keep repeating 400 is not 200. You obviously didn't conserve the momentum. Explain where it went. Explain what is the real force of the spring. Is the real force of the spring compressed this much? Is the real force 400 or is the real force 200? Or is the real force 100? Because I could put a half mass, I could go in even lighter and I'll get even less momentum. And I could go a little bit heavier and I get a little bit more, up to 2, a total of 2. I can't do any squaring thing. I can just get a total of twice the momentum. It's ludicrous. Fucking ludicrous. It's a madhouse. Yeah. I'm Charlton Heston in the cage, planet of the silly monkeys.
Would predict. I agree. Your model does not predict these outcomes. So what's wrong? Is it your model or is it reality? You literally...
He's still backing it up. He's still saying there's no possible way my data could be incorrect because my data is perfect because I'm perfect and I did it and it has to be correct data and you can't accuse my data of not being perfect data. Even though, yeah, my instruments are buggy. Fuck. Face palm. Just amazing.
Throw out the data saying these numbers aren't good. You have made no demonstration.
Okay, so this is just bullshit. I've drawn it over and over. I say turn it upside down, drop the 400, drop the 200. They can't weigh the same. One is 200, one is 400. They can't weigh the same. Dear, 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 dear. Amazing.
That those numbers are actually not good. We've got two possibilities. Something is wrong with the data, or something is wrong with your model. You have done nothing to actually prove that it's the problem with the data and not the problem.
Yeah, I haven't proven that the anything experiment doesn't work. Yeah, it's true. I haven't done that. Because I don't have a satellite in space and all that kind of crap. So again, you want me to do some rickety put together experiment. Well, frankly, I did do it. Okay, I did it with ballistic pendulums. All right, and I couldn't make the 133 thing happen. Okay, so I used steel rod into steel rod, and I didn't get any free momentum. Shit.
Problem with your model. Okay. Those sensors are quite well calibrated, and
You didn't show that. So you can say they're quite well calibrated. You didn't show it. You didn't show pushing the cart into both sensors to see if they read the same velocities. You didn't do that experiment. You didn't do that test.
you make some mention a little bit earlier, or in some other video, where I mentioned how the sensors are pointed at each other, so sometimes they can interfere and cause, not as accurate data.
You said that. That's right. So you're just repeating the fact that there is some reason to doubt, and you have no backup way to measure the velocities. And yet you're going to be this arrogant and say, I'm sure my data is correct. And you're not going to address my argument that you're saying you don't believe in conservation of momentum. There's no way around it. 400 does not equal 200. You have to say the words. Springs don't conserve momentum. I can get different amounts of momentum merely by putting heavier or lighter things in front of the spring, and I'll get all kinds of momentum numbers.
But we can detect that. The data gets noisier or just goes completely off scale high, so we can detect when those sensors are interfering with each other. In fact, in one of the tests, we do that, and we do get a little bit of interference, and I say, that data is a little bit messy, let's try another data sample.
Right, so now he's going to tell us that he's tested it all the ways you can test it, and he's found all the flaws, and there's no way it could possibly have made an error somewhere. Fine, okay, go ahead and go ahead and say that, but at least be consistent and point out how, yes, you have proven that springs don't conserve momentum. Just give me that sentence, okay, and I'll ride with that for the rest of my life, because you're not going to be able to win on that horse. That horse died, okay, when Newton was born. That horse is dead. So write it all you want. Because you're not going anywhere with that lie, frankly. That you don't have to conserve the momentum. It's such a simple experiment. That springs don't conserve momentum. That's your fucking direct statement. Have the balls to say it directly. Because that's the only way you conserve kinetic energy is to destroy the conservation of momentum. If you conserve the momentum, you have to destroy kinetic energy. And if you conserve kinetic energy, you have to destroy the momentum. Fact. Fact you're ignoring and dismissing, not responding.
And see if we can get some cleaner data. The data that I was actually quoting was very, very clean and showed no evidence whatsoever of having any substantial error in part of this. But that's kind of a side part. Let me get back to the
Well, Veritasium had a bet with a guy over the stupid air car thing. You want to bet on it? We'll have somebody else do the experiment and see if they can break conservation of momentum too.
point that I really, really want to make. Again, your response to my experiment was that my experiment couldn't be right because it goes against what your model would predict, and you literally...
It goes against conservation of momentum. It makes momentum meaningless. It's a meaningless idea, momentum, okay? It undoes Descartes, Newton, and Galileo. It puts them all into some kind of toilet where they didn't understand reality. So in spite of the fact that they had a complete misconception of reality, they got all these right answers. So yes, it's a ludicrous thing for me to concede. It's ludicrous for me to concede that you have proven there is no conservation of momentum.
Throw out the data saying these numbers aren't good. You then make a number of different claims about what would happen if you ran the experiment in reverse, and according to your model...
Thank you. No, according to physical reality, 400 momentum cannot possibly compress the spring the same as 200 momentum. Can't happen, never will happen. You're being so intellectually dishonest to defend any hope that that could ever be true. That I could take 400 momentum and compress the spring exactly the same as 200 momentum.
What should happen? You seem to think that these statements of what should happen according to your model constitutes data. It doesn't.
Whatever. So more of this bullshit about this fake, crappy data. Okay, you have no data proving it takes 4 times the fuel. You have no data. You have no experiment. You have no nothing. And here you are claiming that everybody should start now. Oh, start proving the case 350 years after you make the claims. Okay, and this proof is garbage. It's fine. Like I've said before, maybe springs don't conserve momentum. Maybe this is a real thing that we all should know, that springs don't work very well. But say that. At least be honest to what your experiment shows, which is I will not have a consequence where in any way momentum is conserved, because I can't reverse it. There's no expectation that 400 momentum, which is essentially weight, there's no form of 400 momentum that I could create that's going to compress the spring the same as 200 momentums. No matter what objects I use, I can't do that.
Data constitutes data. Actually going out, setting up a...
Data is data. Oh, amazing. Amazing. Talking about evidence when in 350 years they have compiled none. 0. They have nothing to show you. Nothing. And they talk this shit about how I should prove something when they've proven nothing.
System, taking a measurement, that is data, not your claims. I agree.
Okay, no, your claims. They're your claims, okay? On a rickety experiment, you're claiming you proved no conservation of momentum. A bold thing to claim, okay, and you've proved it with a rickety experiment, frankly. It's rickety. Compared to what the physics standard should be, it's pretty fucking rickety. The fact that you have no backup way to calculate the velocities is just so obviously very unscientific.
If your model of momentum and energy were right, something would be really, really weird with the results that I got. But...
Yeah, that's right. It would be really, really weird. And it's really, really weird even for Professor Lewin, I think. If I say to Professor Lewin, look, I have something with 400 momentums, and I have something over here with 200 momentums, and I'm going to crash them into a spring. and they're going to crush the spring exactly the same amount. I think Professor Lewin would say, "Are you a flat earther?" I mean, you talk about intellectual dishonesty. He's just evading the subject entirely.
You have given no actual evidence that there was any problem with the data. Let me do a comparison with how off that method of trying to resolve the question is. Because
you've already done this baby talk. Okay, you can talk about UFOs, or you can talk about some other thing. No, we have a real experiment here. We have a real data that you got. I said reverse it, and you didn't explain the reversal. You didn't explain how the 400 momentum would compress the spring exactly the same as the 200 momentum. You didn't explain how that would happen. Where did you explain how that would happen? Where? Oh, that's right, you didn't. Shit. I mean, I'll take a break. I mean, this is just so tedious. I mean, I can't, this is such arrogance that he's going to go pontificating about how to be reasonable and how to judge evidence when he can't do it right. He's doing it completely based on, it came out my way, so it must be a great experiment. That's all he's demonstrating. He isn't demonstrating anything else. He's not demonstrating how it was a great experiment, that his instruments are beyond a reproach. You can't possibly question my instruments. You can't possibly question how I did the experiment. Of course I can question it. God damn. We can't question the Eddington experiment? Whoops, I dropped that slide. Yeah, I was looking for 10,000 stars and I got 1,000. That's okay, isn't it? I mean, it's only a 90% degrade in my data. What's wrong with 90% degrade? Makes it more fun. A little more challenging. Shit. Yeah, take a pause. Fuck. God damn it. Alright, so let's just understand. 400 and 200 is clearly not conservation of momentum. So he really can't say the two experiments demonstrate conservation of momentum, because it obviously doesn't demonstrate that. It demonstrates exactly the opposite, a non-consistency in the momentum. So he has to say the words, if he's going to be at all intellectually dishonest, that he doesn't believe springs conserve momentum.
Is which of our models is correct, and we're trying to get data to see which of those models is actually able to predict the outcomes of experiments. Let's say I made the claim that the sky is yellow, and you make the claim that the sky is blue. And I say, no, it's not blue, the sky is yellow, I'm very, very insistent on it. And then you go out and start...
so what? So we just measure the frequency of the light, and then we decide what the frequency is, and then we say, well, you can see that it's yellow if you want, but it's not.
Collecting data. You take pictures of the sky, you compare the color of the sky to color swatches of blue and yellow and show that it's consistent with the blue. You take a spectrum of the sky and look at exactly what wavelengths of light are being emitted from the sky and show that they match with the blue part of the spectrum and how those colors mix.
And the wavelengths are really frequencies or periods. Okay, it's not a wavelength, it's a frequency.
In our eye, you gather all that data and say, look, here's my data, the sky is blue. And imagine that I responded, no, your data must be wrong because we all know the sky is yellow.
Okay, that's not what I did. Okay, I pointed out the critical flaw, that I can't reverse your experiment. It's like me showing how your color chart changes color. I showed how 200 is not 400. I pointed it out. I point to 200 and I point to 400 and I say, look, see, a 2 is not a 4. These are not the same numbers. These things can't be produced by this unless you want to say the words that the spring does not conserve momentum. You have to say those words to be honest.
For 300 years, people have been saying the sky is blue, but I actually know, they don't actually have any evidence for it. I actually know the sky is yellow. And no one ever tries to address my...
I know 400 pounds does not weigh 200 pounds. I know something with a mass of 200 pounds is not going to compress the scale 400. I know that. You'll never convince me of your fable that 400 equals 200. I won't believe your fable. Okay, there's nothing in the material universe I've ever had contact with that indicates to me that 400 is 200. So you have to say you didn't conserve the momentum. The two experiments do not show any consistency regarding the conservation of the energy created by the spring. The force created by the spring.
Arguments about the sky being yellow. Wouldn't that be an absolutely ridiculous response? Wouldn't that be intellectually dishonest? That is precisely...
All right, so he's calling me intellectually dishonest because I say 17 times now, 2 isn't 4. You can't say there's conservation of momentum. 2 is not 4. In his case, 1.2 and 3.7. Those two numbers aren't the same.
Precisely what you are doing with this data, with your responses to these experiments. You're saying...
No, you're saying nobody can ever critique your experiments because you'll recite this poetry at them if they do. You won't explain how you could make a mistake. You won't concede that's possible. You'll just pretend that everything you did worked perfectly and therefore there can't be any accusation of an error. I mean, fuck. That's all you're doing. You're demonstrating it right now with this lame, pigeonhole-y bullshit that somehow I'm not pointing to the numbers and saying 2 doesn't equal 4. So until you explain how 2 can be 4, I'm not going to believe it.
The experiment can't possibly be right because it doesn't match with your model. We're using the experiment...
It doesn't conserve momentum. Clearly, it doesn't conserve the momentum of the force that compressed the spring. The force that compressed the spring is not revealed consistently in the two experiments. It's revealed very inconsistently. There is an inconsistency in the data regarding the conservation of the momentum. Fuck.
To determine whose model is accurate. That is the entire point.
No, that isn't the entire point, frankly. It really isn't the entire point of these individual experiments. The individual experiment is it a reliable source of the truth? Is it illustrating the truth? That's all we want, is an illustration of the truth. You're saying that your experiment is above any kind of critique, that it cannot possibly have been incorrect. I'm saying, what do you base that on? You don't have anything to base that on but your own arrogance. Because I've pointed out reasons why it can't work that way.
And again, you have admitted that the data that I gathered matches with my model and does not match with yours.
It does not match with conservation of momentum. So he just keeps ignoring the argument. 400 is not conserving 200. 200 is not conserving 400. These are not conservationally consistent numbers. I mean, god damn, the thickness.
That is why I'm saying you're being intellectually dishonest. You might not intend to be doing this, but that is absolutely what you're doing. So, I've made a couple more times...
That's fine. I mean, I'll just keep making videos showing this lie that you keep propagating. That you conserve the momentum when you clearly didn't conserve the momentum. So I just keep showing the lie. Like I said, maybe it's true. Springs don't conserve momentum. Maybe it's true. Okay, the fact is physics hasn't done enough experiments so I can go find the experiments to prove it. Now, Hooke's law does seem to demonstrate pretty clearly that there is an obligation here and that momentum is in fact weight, so there's really no way to avoid the conservation law and Hooke's law. But I'm just saying, let's say if I just conceded that it's possible that springs don't conserve momentum, you have to at least have the integrity to say that's exactly what you proved. You proved they do not conserve momentum. You proved it. If your experiment is correct, momentum was not conserved. That's the fact you keep ignoring. Clearly, the two experiments do not conserve whatever that was in this spring. It is not the same amount that comes out. How the fuck can't you get that point? The spring is compressed the same amount and it produces different amounts of momentum. How can you say that's conservation of momentum? How can different amounts be conservation? God damn it.
Just to mention a few things, a few other things that you've mentioned. So let me kind of poke through a couple of these. So if we go back to let's go back to 510. Let's run here.
So those are the results he got. Now, my simple argument is that's not possible. Springs can't do that. Okay, they basically feel weight. They're compressed by weight and they push with weight.
That is your model. And your model, we have demonstrated.
No, that's been proven by experiments demonstrating Hooke's law. So every time you put a weight on a spring and it expands, you're proving that consistency and that reliability, that springs measure weight. That's what they do. That's why we use them as scales, is because they do measure weight. Hold on a second. All right, back. So again, I've made the point. It says right here in the drawing, 400, 200. It's weight. If I reverse your experiment, it's like saying 400 pounds will weigh the same as 200 pounds. The spring will compress the same amount back to the original amount that the experiment was started with. How can 200 pounds and 400 pounds compress the spring the same amount and put the spring back to its original condition? It can't happen.
It is not consistent with the data. It happened. That was the data that we got. So which is incorrect? Your model or reality? Let's go to
again, so it's just so arrogant. I mean, it's just so fucking arrogant. Any experiment he does is right. Any experiment somebody else does that proves him wrong is wrong. I mean, this is just such bullshit. I mean, I'm pointing out the glaring problem the experiment has. You can't reverse it. Did he respond to that in any way but just to say it and then ignore it?
on the 8-minute mark, so around 8:03. Let's look at this one.
And compress the spring the same amount. Momentums are essentially weight. I mean, I don't know, you don't want to concede the point, but I don't know how logically you escape that one either. So why would somebody argue that springs measure weight?
I do not concede that point. Momentum is not essentially weight. In your
Okay, so what is it then? I mean, I can duplicate it perfectly. So again, I already pointed this out, but I mean, I can duplicate what happens in gravity right here. I can duplicate the weight. I can create a momentum that I can give my body, and I'll weigh 100 pounds. Let's say I weigh 150 pounds. I'll weigh 150 pounds. The magic number, by the way, is 1 mile an hour. So I give any mass 1 mile an hour horizontally, and it will compress. It will create an impulse compression of the spring that will be exactly their atomic weight, their atomic mass. Exactly. 1 mile an hour. Boom. I weighed you horizontally. Damn it. Continuing.
your model, it might be, but in models that
I have made the argument from conventional physics. Do I actually have to play the Lewin clip for you? And then you can argue with Compressor Lewin, and you can tell him, no, you don't have to conserve momentum. That's just a silly idea.
physicists use and that scientists use, they're different quantities with different units. Momentum is mass times velocity. Weight is the force of gravity acting on an object.
So again, no, I'm just arguing that weight is what a scale reads. And it can read this way, or it can read this way. Now, gravity is a constant force, so it shows you the weight continuously because it's a constant force. And obviously, forces I put in this way aren't going to be constant forces. They're going to be impulses. But I can weigh you this way. I just give you a velocity, and you will have a weight.
Mass, also different. That is an object's resistance to changes.
All right, so this is just out of the textbook jargon, okay? He's really not going to interact with any of my detailed explanations of how these things aren't exactly the way you're saying them, isn't exactly the way it is.
In motion. These things are different, and if you want to be taken seriously...
You want to say they're different, you can say they're different. You have no evidence they're different. You have no evidence I'm wrong. You haven't proven me wrong. You haven't shown me wrong. Blah, 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 blah.
Seriously, you have to be as specific as you can with your definitions.
Yes, I've gone through all that. That's what all the drawings are about, is the specific part. I specifically pointed out that I can't make this spring compress the same amount when I hit it with 200 momentums and then I hit it with 400 momentums. 400 momentums will not compress the spring the same amount as 200 momentums. Won't happen, blah, 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 blah.
We all have these definitions, and us as a community have decided that these words mean different things. If you're using them in a different...
Look, it's all about the fact that your physics has produced no evidence. All right? And the fact is that these experiments will get done finally. Finally, somebody's going to do them, right? So we just had the idiot that you think you praised him as a good demo of physics. He just did a demo where instead of 4 to 1, he did 5 to 1. He got results that were 14, millimeters, out of my prediction. Every bit of that extra velocity is now going to be taken off, and he's going to find that my prediction is actually 100% correct. All right, so, these experiments will get done. I mean, Brozo did half the lever experiment, a little different, but the same idea. 19 to 11. That's pretty close to 2 to 1, you'd have to admit. I'm just saying this is going to happen, all right? And all this crap you're saying about how your experiments are beyond reproach, you're going to have to concede, well, I guess I was talking shit.
Different way, you have to be more specific because it makes for a very, very muddled...
No, you don't have to do anything specific. Again, you say that these experiments that you're doing are proving something. You just prove springs don't conserve momentum. You won't say the words, but that's exactly what your fucking experiment proved. If it's an accurate experiment, it proved it. Damn it.
Argument. So, for example, if I said, I'm defining this to be a dog, well, I can try to do that, but it's really going to be confusing.
I already used these analogies, okay? I already used duck and platypus. And I'm obviously arguing that Leibniz couldn't tell the difference because he really didn't think about it much. So he got fooled, okay? And frankly, you're worse fools because you have the technology to know better. You have the life experience to know better than to be fooled by 4 times the distance. 4 times the distance when it's only twice the time, twice the velocity, and when it hits the ground, it's going to compress the spring twice as much. It's going to weigh twice as much. 2, 2, 2, and you got to insist on saying 4.
When I talk about, trying to, pet my dog or take my dog for a walk, if we're using words in different ways than the standard usage, that makes for a very confusing description.
Yeah, and whose fault is this? Again, you sit there and claim you own these words, okay? Obviously, Newton said quantity of motion, and he said momentum is the motion of a body through space. And now you're claiming kinetic energy is the motion of a body through space. I mean, you're stealing the definitions.
let's jump ahead. Actually, let's just play this a little bit more.
Thank you. Yeah, it'd be nice if you just played the argument, because it wasn't more than 7 or 8 minutes long, frankly. I made it nice and small just for you. You could have just played the whole argument. But that's essentially what momentum is weight. And springs measure weight, and we know that. But they measure momentum. So he's shaking his head that springs don't measure weight. I mean, Hooke's law, scales. There's a spring in here. I mean, damn. Oh, I mean, whatever. Whatever. I mean, it's clear that you can't do this. And I just saying that, okay, I've made this argument 4 times. You pay no attention to it, and you just, okay, I'm dismissing your experiment as shit without giving you an explanation. No, I've provided the explanation that it doesn't make any sense.
You've made the claim 4 times. You haven't actually provided any data at all. You haven't done an
It's not my obligation. It's not my obligation. You claim you have free energy. I don't have to prove you don't have free energy. I just have to claim your experiment's a piece of shit. And I point out the shitty part. The shitty part here is you're claiming 5 pounds weighs 10 pounds. I'm saying, no, it doesn't. It's a clear argument.
At least, I haven't seen your entire work. Again, as you said, there's a lot of it. If you have done an experiment where you're actually making measurements and taking data.
Yeah, I've done the experiments, and we all found, okay, all the amateurs doing experiments should be able to concede that whoops. There's a lot of whoops to have in here, okay? Just even launching balls, okay? I was launching balls to see how far they roll. Well, you got to get the velocity right at the beginning because they don't lose their velocity at the same rate. So you have to understand that. Then you have to understand that, well, the launching device has to have a quick release because you really can't do it by hand. I mean, there's a whole bunch of details. Details. The fucking physics shouldn't be dependent on amateur experiments. They should be doing these professionally. Should have a professional lever experiment. For fuck's sake, they have all these high-speed cameras, all this technology. They're wasting it on, let's blow up a soda bottle. Let's blow up a squirrel. Let's blow up... Yeah, they just blow shit up. They entertain juveniles.
I'd love to see it. I have paid attention, and you're not providing an explanation as to why my experiment worked. You're simply...
No, I'm pointing out that there's a law of conservation of momentum. My whole life it's made sense. You conserve the momentum. You're saying springs don't do that. All the spring interactions I've had with springs, you put the force in, you get the force out. That's my argument. You're saying they don't work. I'm saying, well, every time I've played with a spring, it's worked.
Saying that your model does not agree with the data that we got. I agree. Your model does not agree with the data that we got.
All right. Hooke's law doesn't agree with the data you got. 4 does not equal 2.
So, let's look at the next one. Let's go to 10, just around 1040.
So it's too bad he didn't play the 10-pound, 5-pound argument. So it's right there. He's basically saying 400 will compress the spring the same amount as 200. So I can reverse the experiment, and the 200 momentums coming into the spring will compress the spring exactly the same as the 400 momentums hitting the spring. That's his fucking argument. It's fucking ludicrous. I mean, I have to make up his argument, right? Because he doesn't have one. But he's clearly totally ignored the most important part of my argument, the absence of conservation of momentum. Totally ignored it. When none of you believe in it. I mean, it's just a joke. Right, so I'm saying conservation of momentum. You clearly don't believe in it. You clearly don't think it's a law. And it's just, why do you pretend momentum is something when you give it no reality at all? All right. So I don't, it's really impossible, this circumstance where they don't have to respond to anything I say or anything I draw. They can just quote mine a sentence and play their little games. That's what he just did here, right? So you just saw him quote mine. You just saw him decide what little bits he'll deal with and what bits he won't. I mean, it's, pathetic.
First off, I have watched a fair amount of your content. As you've mentioned, you say things over, you've made these arguments multiple times, so I don't need to watch the third or fourth or fifth time that you've made exactly the same argument. I've responded to your arguments with experiments.
Okay, so again, no. There's no point. I want you to say the words. You're lying. Okay? You're saying you conserved the momentum. You didn't. It's a fact. So quit lying, okay, about the fact that momentum was conserved. It wasn't.
With data. And you seem to refuse to honestly address it. Again.
All right, so I'm just going to say, you refuse to honestly address that 200 is not the same as 400. These are not conservational outcomes. Conservation would require 200 and 200, or 400 and 400. Conservation would require that.
Provide no experiments or any demonstrations that your model actually makes.
Okay, so again, I'm sorry that you haven't watched all the videos, but again, I'm going to make the argument there's absolutely no point in science being done in this basement in terms of experiments. That's just stupid. And the fact that your science hasn't done any of these fucking experiments is an indictment to your credibility. How credible can you be? You show up at court and you draw a picture of a gun and put it on the table. And then you draw a picture of a knife and you draw a picture of the blood. You don't produce anything real.
Makes verifiable predictions. And as for the quote mining part, you've mentioned this a couple of times where people will post clips. Whenever I watch a clip, I always watch at least a few minutes before. And
yeah, you watch, you don't play it. So I'm just saying, where did you deal with the point? The absolute point that you're basically saying your experiment proved that 10 pounds weighs 5 pounds. That the two objects will compress the spring the same amount. 400 momentums compresses the spring the same amount as 200. That's what you fucking prove. That's your fucking statement. So say it overtly. Momentum is not conserved. And yes, we live in a universe that is a wackiverse.
At least a few minutes after to make sure I'm getting the context, to make sure I'm getting a at least a somewhat fuller view. I don't know what your schedule is, but I don't have time to go through the...
Oh, I'm just saying, well, yeah, we all have to do this. I have compromised a gigantic pile of my life doing physics research. A gigantic amount of time I have spent thinking about. I go to bed every night thinking about these questions. Every single night. So, yes, maybe I'm more devoted than you. I didn't ask you to make hours of videos. I asked you to respond to direct questions, and you didn't do it, and you still haven't done it. You spent 40 minutes in this video, and you didn't get to the key point made, which is 200 is not the same as 400. Those numbers can't be called conservation.
Usually at least an hour a day is what you post. Yeah, unless I see something that's new, that is a new kind of argument, or looking at data and experiment, I'm not going to be that interested. So, sorry about this.
So he's basically just saying, I'm not interested. I don't care that Eddington's never been repeated and his experiment was shit. And it was shit, frankly. 10% of the data quality. 10%. And these liars won't concede, oh, we really should test this, huh? With a real direct test. We should really duplicate Eddington's visual photon experiment. Not in the corona of the sun, not, any of that crap. No. Do it right, do it from space. Never done. Never attempted, we're supposed to believe. It's never even been attempted from space. Even though there's 400 times better resolution. Where have you in any way addressed any of these critiques? So you're running from every bit of the subject. You don't take any criticism of your science. You don't respond to it. You don't care. You don't wish to do anything but pretend you have integrity, but you won't show any.
So, I think there was something at 11:36 that I thought was interesting.
Here, and he's conceding that there's some curiosity here and saying he's willing to do the experiment. That's all good. And I pointed that out in the video.
So this is in reference to me talking about how I'm going to do this lever thing, and the specific quote that I wanted to.
All right, so and you should understand that what you're going to have to prove is that levers don't conserve momentum. That's the only way your kinetic energy theory can survive the lever, is you have to prove the lever doesn't conserve momentum. Just admit that's what you're going to attempt to prove. Admit it. Because there is no choice. The two things can't both be conserved when I have a 1 mass and a 2 mass on the lever. You can't conserve both. Only one of them can be conserved. Only one of them can be real.
Kind of deconstruct a little bit.
Yeah, so, instead of posting the video that was actually a response to this last comment, so he's conceding that there's some curiosity here and saying he's willing to do the experiment. That's all good. And I pointed that out in the video. So he plays that clip twice. Ignores the weight argument. Yeah. He doesn't. It's still on the screen anyway. 10 does not equal 5. 10 mass will not compress the spring the same as the 5 mass. 10 momentums will not compress the spring the same as 5 momentums. And post the link to that video.
Okay, so he's talking about how he's saying, I'm conceding that there's something weird going on here with the lever. No, that's not what I'm saying. What I'm saying is the lever will give us another way to distinguish, to have an experiment that distinguishes between the predictions of your model.
No, conservation of momentum or conservation of KE. It'll clearly show one or the other. Damn. Amazing. Amazing.
And the predictions of my model. Okay. So this is a way that we can test those two models, again, provided that you're willing to actually accept the results. This is why I hope that you'll actually contribute to the discussion that I'm going to be having on my live stream. You'll be able to, I will...
Yeah, you don't have to worry about me, okay? I'm always game. I'm always ready for the fight. Always.
Make sure that you have an opportunity to say your piece during that. I'm not going to let you dominate the entire conversation.
Yeah, I just want enough time to point out little obvious things that don't do it in gravity, because then you have to subtract the actual weight of the objects and blah, 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 blah. So try to do it horizontally rather than have gravity fuck with it.
But you will have an opportunity to say your piece, and I will try to design a lever experiment that fits your criteria as accurately as possible. At the end of this video, you do go through some aspects of this lever experiment that you'd like.
Yeah, I still don't, it's just, I have to just say, it really is funny, right? I mean, it's like the Ian Gosling guy. He thinks when he does the experiment correctly, that is from 4 times the height instead of 5 times the height, that something's going to happen for his side when it's all going to be on my side. The number is going to go from 40 and it has to get to 27. It's going to get to 27 no problem. It's going to do those 13 little millimeters without any trouble at all, and it's going to be decisive win for me. It's going to prove I'm right, or I'm a lot closer to the truth anyway, and it's going to prove KE even more preposterously wrong. So it's already wrong in that he didn't get the twice the energy, he only got 1.5. So it's already way off. I mean, amazing. And this guy actually thinks levers don't conserve momentum. He actually thinks they don't conserve momentum. I mean, it's just an amazing statement, right? He actually thinks that I could lift a 20-pound weight at 5 miles an hour with a 5 mile an hour going 10. He actually thinks a 5 mile an hour going 10 will make a 20 mass go 5. He actually thinks so. He actually thinks so.
See, I appreciated that. There were a couple of things in there. I have this on my list. Use a small lever. Set up as a horizontal launching apparatus. So
small, I don't know if that's a great idea, frankly. I'm not. I didn't say anything about no small levers. Light is what I said. Okay, here's one that can't possibly look. That's the first test, right? The first test is you put a nail in the lever and you have it horizontal, a piece of nylon for a bearing, something to keep it so it swings, fairly simply. A bicycle wheel, even. You could just use a bicycle wheel with a straight rod on top of it, or well, see, that's way too heavy though. So forget it. Ignore that statement. You want it as light as possible, but you want it long enough so you take any of these, hard measurements out. The measurements get much easier the longer the distance, so you can be much more sure of your measurements. So short lever, not necessarily a great idea. Okay, continue.
Oh, okay, I can do that. A small lever to minimize losses so it doesn't steal energy. I got that. But
yeah, light, not small. I have a lever hanging over there. It's, a meter long, but it's hollow aluminum. It's very rigid, but really light.
There are going to be limitations since during the collision we don't want the lever to actually break. I also don't think you want the lever to flex.
I don't think any of that's going to happen if you just use pendulums swung into it with weights of, 10 grams or something. A few ounces.
At all, so that's going to be a little bit of limitations in how small I can make the lever.
Look, you make the lever, and the first test you do is you just put the pendulum through and you see how much energy it loses. So you take the velocity going in and you see what the velocity after it hit the lever is. And as long as that number is 2% or 5%, as long as you only lost 5% to the lever, you still have a viable experiment.
Again, there are parts in there that I will try my best to actually address, but again, I do hope that you'll take part in the discussion that I'm hoping to have. One or two, let's do one more clip from here. Again, I watched the entire thing for this, so please don't accuse me of not watching the video, but later on it gets into more individualized comments.
Again, I have done the videos on purpose. I'm doing all the drawings in the beginning now, so I'm making it easier for you to see the arguments and respond to the arguments. So you don't have to play any of the rest of the video. Just play the beginnings where I'm doing all the drawing.
Doesn't seem to be loading. Let me pause this for a second.
We'll say I believe.
Okay, sorry about that. So we were going to 1302. Sorry about that little hiccup.
And I'm pointing out how, no, it doesn't, because your experiment can't possibly be what you say it did, can't possibly happen. Claiming without evidence. So again, he says this crap. And what's my evidence supposed to be, exactly? I mean, you do a magic trick, okay, and I call it out, say, yep, trick, here, the pigeon's in your sleeve, and you, what, pretend I didn't point that out, or what do I have to do? Do I actually have to duplicate your trick? Why do I?
So what we're talking about here is saying that under your model, it can't possibly be done. I agree with that.
Again, it's not my model, so you have to keep saying it over and over again, but it's what physics says. physics, the only parts of physics that make any sense to me are these parts where Professor Lewin says something like nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. Those are the only parts of your physics that make any sense to me. And you're saying those are nonsensical, that Lewin's wrong, that springs finagle momentum all over the place.
Your model, that spring experiment where we launched the objects off of each other and the kinetic energy was conserved, in your model, that shouldn't happen.
In my model, you can't create free energy. Yeah.
But sorry, that happened.
So again, he says it again, that happened. So his argument is my experiment can't be critiqued. And it doesn't matter that I can't reverse it rationally. That I can't explain how 400 weighs the same as 200. That 400 compresses the spring the same as 200. I don't have to explain that. That's what he's saying. No, that's exactly what you have to explain. I shut up about it as soon as you explain that. But until you explain how 200 will weigh the same as 400, I'm going to keep doing this video over and over and over again. And I'm just going to show how you're not responding to the argument.
So, your model is wrong. You talk about pointing out magic.
You're not responsive to critique. That's my accusation. You're not responsive. It's totally non-responsive.
Tricks, but you just said it was a magic trick. You didn't actually demonstrate things. You say...
I demonstrated that 2 isn't 4. That's all I have to demonstrate. That your experiment says 200 equals 400. I just have to say, no, it doesn't. I don't have to do any more than that. You have to resurrect the integrity of your statement. Your statement is 200 equals 400. That's what you proved. Well, show me.
Things like, oh, look, there's a rabbit in his sleeve. Where?
Reproduce the experiment in reverse, okay? Push the masses at those velocities you claim there was. Do it in reverse. Do the experiment in reverse and show the spring being compressed the same amount.
Where did you actually do a measurement that showed that my measurements were wrong? Here's an idea. These carts, these are the...
are shit, frankly. Sold for insane prices for fairly shitty carts.
Exact carts
with fairly shitty springs, frankly.
That I was using in that video. And they are, if I measure this one is approximately 16 and a half centimeters long. So
who cares? Look at the little springy thing, right? It's a cheap, cruddy little spring on a stick with a plastic thing at the end. All kinds of mayhem there, right? Because if it compresses a little too far in or the carts aren't hitting each other, the spring, when it's released, will end up banging into the other object. It won't push it. It'll bang into it. Very different. Hitting something and pushing something are not the same thing. So that's another word. See, that's something you could quote from me. And I could say hitting and pushing aren't the same thing. And then you could shake your head and say, no, they are exactly the same. Yeah. Well, we have to have the experiments to prove it, don't we? And your physics doesn't do any of those experiments.
The length of this cart, so again, this is a 30 centimeter ruler, that is 16 and a half centimeters long. So what you could do is go through my video, go frame by frame, use the...
Amazing. You don't realize that in your video, the size of the experiment is the tiny portion of your video. It's a little thing in the corner. There's no way to do frame rates. Amazing.
60 frame per second version, and you can go through it frame by frame and say, this is how many frames went by, and you can watch the video to see how long did it take to go one cart length.
Yeah, we all have done all this for 2 years. We've done this. Been there, done that. And the funny thing is I can find 15, 20 videos of the same experiment, and all of them have different kind of answers to the question. different truth.
You've got your change in position, and if you know how many frames in the frame rate, you can find the change in time. That would be a fantastic way to demonstrate that the velocities that I was gathering were wrong.
Right. So only you can do that because only you have the original clip, I would imagine, right? I don't know. It must be an original clip of it, the experiment. You must have an original video of it. We don't have that.
Try it. See what you get for your results. Make a video on it.
No, I'm just going to keep saying 4 isn't 2, okay? So I don't have to say any more than that. 4 does not equal 2. 2 does not equal 4. I don't have to say any more than that. You're saying those two numbers produce the same impact on a spring, 2 and 4. Same impact. I'm saying no, they don't. I don't need to say anything more. I think anybody reasonable would agree that 2 and 4 are not the same number, so you have to concede that the spring does not conserve momentum. Say the words. The springs don't conserve momentum. Say it. You're going to prove, right? Your next experiment, you're going to prove levers don't conserve momentum. You're going to prove it. Because you have to. You don't have a choice. Your theory is done as soon as you prove that levers conserve momentum. If levers conserve momentum, your theory is over. Because then it's a free energy theory.
I'd be very impressed if you were to do that particular experiment. That would be what kind of data we...
So it's just kind of funny and ironic, right? I mean, you know, everybody who's been in this for 2 years knows we've done this frame rate thing hundreds of times, and it has all kinds of liabilities based on camera angle, stretches, all kinds of things that can make a mess out of doing it. The fact that videos, after they've been edited, screw up the frame rates. There's actually frames that are 0 frames. I mean, you know, all kinds of messes.
Need to actually refute my experiments. Actual data, not just you saying my model.
2 does not equal 4. I don't have to say any more than that. Reverse your experiment. Reverse it. Just do it even theoretically. Theoretically reverse it, okay? As a thought experiment, reverse your own experiment and say to me honestly that you believe 400 momentums will compress the spring the same as 200 momentums. Say those fucking words and we're done arguing. Because I don't need you to believe in momentum. I just need you to concede that you're saying springs don't conserve it. That's all I want out of this, is your admission that you claim springs don't conserve momentum, that somehow the momentum disappears from the spring.
Does not match this data, because we both agree on that. So I think I've demonstrated that your method of trying to determine whose model is correct by simply saying, my model can't be wrong.
No, I'm simply saying I saw you pull a pigeon out of your sleeve. I saw you say 4 equals 2. That's all I needed. I saw you do something ludicrous. 4 does not equal 2. You're saying you conserved the momentum. You clearly did not.
So I'm not going to believe the experiments unless it matches my model is nothing but concentrated confirmation bias. It is not a...
I'm rubber, you're fucking glue. I mean, that is just such bullshit. You're the one layered, just covered in confirmation bias. Your experiments are the truth. Somebody else's experiments are wrong. Again, I did the ballistic pendulum experiment on my porch. No, right in this basement. Right over there, I did it. All right? And I didn't get any of this free momentum crap.
Effective method. But I wanted to mention a couple other things that I've seen in repeatedly in some of your videos, both the one I was looking at and some of the other ones. You repeatedly claim that I've ignored your responses, saying I haven't talked about spring.
You just did. You just totally ignored the fundamental point, which is 400 does not equal 200. You cannot say the momentum was conserved between these experiments, that there's the same momentum in the two experiments. There obviously is not, so you can't say the momentum is conserved. The spring has one compression. You got two different numbers. You can't call that conservation of momentum and be honest. That is dishonest.
How springs store momentum and how levers don't conserve energy. This is a flat out lie on your
Okay, so it's just bullshit. No, it's a flat out lie on your part. You have no experimental evidence in 350 fucking years. You've claimed this magical thing happens. You've claimed that the 5-ton train going 10 miles an hour would beat the crap out of the old 10-ton train going 5. It'll lose the tug of war. No, it won't. You don't have any experimental evidence showing that this inverse mass to velocity ratio means anything else but always a tie. One atom going 1,000 miles an hour will push just as hard as 1,000 atoms moving 1 mile an hour. The tug of war remains. The flag stays in the middle. Okay? You say the one atom going 1,000 miles an hour should pull all those thousands because it has 1,000 times more energy. No frickin' evidence. Damn it. 350 years, no evidence.
part. I've explained that
No credible, direct evidence.
in my model, springs don't store momentum in the way that you think they do.
Again, it's not about what it stores. Who the fuck cares whether it stores something? We're talking about whether it conserves momentum. Damn it. Which is the same as conserving weight, which Hooke's law proves.
That spring is compressed and it's not moving, it has no momentum. Even if the particles inside are all moving.
Even if the dynamite is dynamite, it isn't dynamite. I mean, there's just no point in having this baby talk conversation about how the dynamite isn't a chemical with potential energy stored in it. Of course it is. When the spring is compressed, there's energy stored in it. No point in having some other ludicrous notion that there's no energy in the spring. Bullshit. It takes energy to keep it compressed. Anything I use to keep it compressed is going to have constant pressure on it. It's going to be under constant stress. If I do it with a piece of plastic, I could take photography images under ultraviolet light and I could see the stress marks in the plastic from it having to hold the spring.
Those motions are going to be randomized in different directions, and those little bits of momentum of the molecules in the spring, they will all cancel out. This was demonstrated in my experiment. I've also talked...
Bullshit. That's just nonsense. You didn't demonstrate any such thing in your experiment at all. Your experiment didn't have any chemicals in it, didn't have anything at all showing how there's no pressure. That whatever's holding the spring compressed isn't under stress. You're going to show that somewhere? You're going to show an experiment where there's no stress? Whatever holds the spring in the compressed state, it's not under stress?
To about levers and how they don't conserve momentum unless the system only has internal forces.
And so whatever that means. I mean, what other forces are we talking about again? What magical force are you going to invent? What is affecting the lever? It's on an anvil. Okay, we're going to make sure the fulcrum cannot possibly move. All right. What is the external force?
Again, in my model, total momentum is conserved when there's no...
Okay, so there's just no point, right? He can't have it both ways. You cannot conserve kinetic energy and conserve momentum, total momentum, however you want to call it. You can't do it if you're putting the energy from a big mass into a small mass or a small mass into a big mass. That's what the mv squared does. The v squared makes it impossible to conserve both. Not possible.
External forces. And at the fulcrum for a lever, there's going to be an external force at that fulcrum point. When one of those masses hits the lever, there's going to be a force at that fulcrum point.
And it's going to be meaningless. Like a brick wall is to a tennis ball. It's going to mean nothing to the tennis ball. The tennis ball is just going to say, I'm going back that way. Now, tennis balls are 25% inefficient, so let's use a hard rubber ball. Okay, that has something like 95% efficiency. You throw it at the brick wall. Who cares what the brick wall does? We know we get all the energy almost back. So this is just a canard. This idea that the fulcrum is somehow going to move somewhere, or the earth is going to move, or something's going to move. No, none of that's going to happen. All the energy will be reflected right back from the fulcrum. The fulcrum will say, no thank you, I'm not going anywhere, here's your energy back. But whatever. That's something all the physicists don't understand.
So that is not a case where we can apply conservation of momentum to just those objects. You ask, where does the momentum go? It would go into the Earth.
Okay, it doesn't matter. It's not going to happen. So when he does the experiment, it's not going to happen. Okay, the experiment is not going to validate his theory. The 5-ton train is in fact going to make the 5-ton train going 10 is in fact going to make a 10-ton train going 5, and the 10-ton train going 5 is in fact going to make a 5-ton train going 10. No problem. The momentum is going to be conserved. Levers actually do work.
Because the Earth is connected through that fulcrum point. The Earth is involved in the collision, so if we wanted to use conservation of momentum, we'd have to involve the Earth in this. Another claim that you've repeatedly made is that I'm being condescending. Okay? That's not my intent. If you think...
who cares what your intent is, okay? You're pretending your experiments are all above reproach, and you're going to insult anybody who dares to say you made a mistake by saying, well, that's like saying the sky is yellow. You can't just say the sky is yellow. Well, yeah, I can. And I can also just say that 4 isn't 2. Shit.
If I'm being condescending, I honestly apologize. My intent is to be as clear and precise in my language as possible, because that's important in these kinds of discussions where we're trying to make specific claims that we...
It'd be nice if there was a pressure sensor that could actually detect any motion in the fulcrum. But, a spring would actually move, which would mean the fulcrum moved, right? So we can't measure the pressure that way. And pressure sensors don't do, the little sensors that detect pressure, the electronic sensors, they don't do instantaneous. They have to average over a period of time. So they can't measure instantaneous pressures. But clearly the fulcrum is going to be irrelevant. No energy is going anywhere besides going exactly the same. The same weight is hitting the lever, frankly. It's the same momentum you're putting in. It's the same impact. Whatever losses the fulcrum can create, it's going to create the same losses for both sides.
Contest about specific kinds of systems. If we're fuzzy with our language, that only causes confusion. So that's what I'm trying to be. Not condescending, but precise and clear.
Okay, and you're precise and unclear in how you've responded to any of the accusations that in 350 years, the pool of evidence you have defending MV squared is insanely meager. There is no water in the pool. There's a rubber duck. There's a dildo. I don't know what that's doing in. There's all kinds of little things in the pool, but there's nothing called water. There's no direct, credible evidence in the pool. And you won't even concede that argument when it's glaring. And I can show, look at a car crash. Car crashes don't show 4 times the damage.
You claim that I refuse to consider alternate points and refuse other possibilities. You talked in your video about how, you're allowed to ask questions and then I give you the answers and that's it. That's all where it goes. When I start public science outreach talks, I generally start with this, saying, what does it take to be a scientist?
You talk to little kids or something. I'm making the point to you, I have done more research on Leibniz and kinetic energy than you have, okay? It's just a fact. I know more about the subject. Right? I don't need your patronizing bullshit, okay? And then you tell me what Newton said when Newton didn't say it. I mean, you just did a video where you pointed out Newton says twice the velocity, twice the force. 3 times the velocity, 3 times the force. And then you pretend that somehow that means kinetic energy is viable. When, of course, it can't be. By Newton's statement. So why didn't you say Newton was wrong?
You have to ask questions, you have to look for answers, and you have to question the answers. I always...
So again, I could just say this over again to you. Newton said twice the force equals twice the speed, the velocity. How the fuck can twice the velocity be 4 times the force?
Always emphasize, whenever I'm doing any teaching, you have to use good scientific methods to try to find out, are your answers reliable? When I start a new course, I specifically tell my students...
Who cares? I mean, my whole commentary is basically saying your whole edifice, this whole thing you call science, is crap. Every bit of it, the entanglement, the bent space, the redshift, like there's no other explanation but more space is being created. Everything, dark matter, neutrinos, it's all bullshit. Entanglement, little ESP particles. Damn. It's ridiculous, science.
If I make a claim, call bullshit on me. Their immediate response should be to demand evidence. And
yes, and you're saying that your experiment, okay, that's a repeat of other people's experiments. I never saw anyone do the, 400 and then measure the actual momentum and say, yes, I made more momentum. I never saw Professor Lewin make more momentum. I mean, I could show his experiment, right? And he used, kind of the same length of compression, but we're not sure it's the same compression. We did in 1 mass to 1 mass, and then they did 1 mass and 2 mass. So you could extrapolate from that experiment. But there was no indication that he made more absolute momentum. So I've never seen anybody make more momentum in the, let's push a spring into 1 masses, 2 1 masses, and let's push a spring. It could be a brick wall. Like I said, we could just make it a brick wall, put the spring in, put 200 in, put 400 in, compress the spring the same amount. I've never seen anybody do that.
Repeat this throughout the course. So whenever we're introducing a new topic, I'll say, well, I've made a claim that this will happen. What should your response be? And I expect the entire class to chime in with, what is the evidence? So I encourage questions, and by questions...
Right, so can you link me to somebody else who did this experiment where they actually measured how much momentum these 2 experiments produced? 2 masses versus 1 mass against a surface. I launch the 1 mass, I get 200 momentum. I launch the 2 mass and I get 400 momentum. Can you show me somebody who's duplicated that experiment? That they got twice the momentum out of the same spring? Can you show me that experiment? That would be confirmation of your experiment. So, in my opinion, you're the first one to do the I prove springs are non-conservational. So shouldn't I expect there to be some confirmation from some other source? That's one of the scientific method things, right? That you're supposed to be able to repeat the experiment. Well, I haven't seen anybody repeat it.
I include points of disagreement, even heated points of disagreement, where I am required to back up my claim. Your statement that I don't do this, again, is dishonest. Now, you don't...
No, there's nothing dishonest, right? I just pointed out how he can't link me to that experiment being done, creating that result. That, a cork gun or something. That somehow, if I put the half-mass cork in, I get 200 momentums. I put the full-mass cork in, I get 400 momentums. Where has somebody done that experiment? I'm claiming no one has. There's no confirmation. And I've watched a lot of videos. Okay, Julius Sumner. Julius, what's his first name? I forget. Anyway. He's got a bunch of videos for kids. Okay, they're not all that bad, though. He believes in conservation of momentum. He'd say that, no, 200, it has to be 200 each time. 200, that's the momentum you're going to get. The lighter thing will go faster and the heavier thing will go slower, but you're going to conserve the momentum. That's what he'd say. In contradiction to what you're saying. And he'd prove it with little toys. He'd bang little toys into each other.
Know all of that other stuff, so it might be an honest mistake. But strangely, you seem to take criticism about the models that you accept as personal insults. You say, oh, you said...
I take the very fact that I have to have this imbecilic conversation with people so dishonest that they won't admit we should have a lot more evidence. We've had 350 years, billions of dollars, millions of technicians, and we haven't provided real evidence. We're lawyers holding up pictures of guns. You don't have anything real. I mean, you're in court and you have nothing real. You just have a story. The story of the bullet with 1,000 times more joules of energy. The bullet that produced thousands of watts of energy. And the gun that did nothing. The little weak, feeble gun.
My ideas are wrong and that's going to annoy me. Well, does that mean we're not allowed to question you? You know, your response is...
Please question me and say, why do you believe what you believe? And I'll show you the experiments that convince me. But yeah, again, the point is we have a vacuum of data, as you put it. It's a vacuum.
To a question seem to be taking it as a personal insult. I take the time to compare what models are we working with and try to identify experiments that can distinguish between competing models so we can do...
Right, well, whatever. I've been doing that for 2 years. Now, what I would like you to do is just draw the lever, okay, and show where the momentum goes. Just show that, okay, I put the 2 mass over here going a velocity, and it hits this part of the lever, and I have a 5 mass, the half mass over here, 2 units of distance, and just show me how it only goes 1.4. That it doesn't get the 2. It only gets 1.4. Show me how it conserves kinetic energy and kills momentum. Show me. I mean, I've asked this question. I mean, I just think that most physicists would agree with this argument, okay? That if I actually produced a lever, okay, we put a screen up, and you can't see what's on the other side, that I could switch a 2 mass 1 unit of distance and a 1 mass 2 units of distance. I could switch them, and you on the other end could be betting your money, that you can predict which one's on the lever. And the argument I would make is no, you can't, because they weigh exactly the same. All you can do is feel the weight on this side. You can't feel anything else. You have to push 1 unit of distance. Do you really think you can know that you can feel the difference? That the 10 pounds is going to feel different than the 10 pounds? Yeah, no, it isn't going to feel any different.
Do an experiment and let the real physical world tell us which one is correct. Which of those approaches sounds more...
Okay, so I'm just saying, the real physical world, they haven't done any experiments in 350 years. They still haven't proven it takes 4 times the fuel to go twice as fast. They can't show you a single experiment. And yet they're complaining about how I should pay attention to all the experiments. Again, it's only your experiment. This is the only experiment I've ever seen, your experiment. Okay, where the same spring produces different momentums.
Reasonable to you. You've claimed that
Same spring compression. Identical spring compression produces different momentums.
Only include data that supports my position, and I threw out other data runs. That I'm not going to show data that doesn't match with my prediction. How did you determine that?
No, what I suggested was, okay, and it was just a suggestion, all right, is that's how you look at it. If you did the experiment and it didn't come out as your theory predicts, you'd say, hey, what did I do wrong? And you'd fix it. But if the results come out the way you predict, you're not going to question anything because everything came out the way you wanted it to. So you're not really going to question it. But there could be something really wrong with it. It could be right for the wrong reason. But you're really not going to investigate. And the only time you're going to investigate is when something isn't consistent with what you expect. So I'm going to argue that the lever is going to show that kinetic energy is not conserved. Okay? You will not make the 20 mass go 5 using the 5 mass going 10. You won't be able to do it.
Do you have access to my computer and can tell what I'm keeping and deleting? How about the fact that the 3 spring cases were all
So again, I never did say he did that. So he's presuming an accusation I didn't make. I just said which the nature of how you appreciate your own experiments is probably like everybody else. If it comes out the way I want, I'm going to assume everything was fine. And if it doesn't come out the way I want, then I'm going to start investigating.
recorded in a single continuous take, and I intentionally did not include any cuts in the editing. Did I just get super lucky getting them all?
Okay, so again, this has nothing to do with luck, but yeah, there is a consistency here, right? He did 3 experiments with the same equipment. One of them just happens to be the free momentum experiment, right? The Lewin 133 happy free momentum experiment, indicating right off the bat to me, woo, momentum conserved there, and then the 400 and 200. So they all have a consistency, which is you're making free momentum. You're certainly not conserving momentum.
Wrong in exactly the right way. I got them all running exactly the right way that works for my conclusion. How many runs did you think I did with that?
So again, it's not about runs. I've already told you what I suspect is the problem with your equipment, that you're not measuring the velocities correctly, that it's not calibrated appropriately, and you're not measuring the actual velocities.
Now, I doubt you'll believe this, but that was the only take doing that experiment. I don't think I've ever, repeated doing an experiment in any of my videos.
All right, so I'm just saying, I never made the accusation that the video you showed us was in any way edited or distorted. I never suggested that. I didn't say that. All I said was when you do these experiments, you have a setup. If the setup's working, you're not looking for problems. If it doesn't come out the way you want it to, you start looking. And I'm saying the looking part probably should be done no matter what the experimental results show. You should maybe start checking, well, is there any way I can test these velocity detectors to make sure they're accurate? And maybe you should have done that.
If something's not working, like if there's an actual technical issue where the sensor is not turning on or something, I edit that out. But where we actually get data, I have never deleted a single piece of data. Again, I doubt that you'll believe this, but for that experiment as well,
I'm not going to keep arguing this. I'm not making that accusation. I'm saying your instruments failed you. I think it's the only reasonable explanation, frankly. So I'm just saying it's the only suspect I could blame. It's not the carts. It's not this. It could be the spring, frankly. Okay, I mean, obviously it's a hitting spring, not a pushing spring. That could be a problem. It's really important that you push, not hit.
Spring experiment where we were launching the masses, that was actually the first time that I'd done that specific experiment with that specific setup, where I had the 2 carts and the spring in between them, and I used the first interaction to calculate the spring energy from the first launch, and then change the masses in different ways to verify the energy equations.
So again, verify kinetic energy, but not conserve momentum. So again, he overtly doesn't conserve the momentum. So explain how you can get away with that. How non-conservation of momentum is consistent with physics general theory. That's what physicists teach, that momentum isn't conserved by a spring with no external forces. There's no external forces in either experiment. The numbers of the amount of momentum are different. It's just a fact. Your obligation is to explain how 400 momentums compresses a spring just as much as 200 momentums.
That was the first time I had ever done that particular experiment in that particular kind of context. I've done similar
Yeah, I haven't seen it before either. Like I said, I've seen them do the experiment without measuring it, right? So Lewin did it just to show that, yeah, half the speed went this way and half the speed went that way. And with the twice mass, half the momentum went this way and half the momentum went that way. But he didn't show the absolute values and to demonstrate that more momentum was created because I put a heavier object in front of the spring.
that have somewhat different experimental setups, but that one was brand new, and that was the first time I did it, and it matched up with my results and didn't match up with yours.
Again, it wasn't conservation of momentum. So again, you could just keep saying it that it doesn't match me. No, it doesn't match conservation of momentum. You have to explain where the momentum what? It's a closed system. You have to explain if 200 one time, 400 the next time, you have to explain why there's a difference in these numbers. How can there be a difference in the conservation of the momentum?
Lastly, and you've done this a couple of times, of posting comments on my videos late in the evening asking me to, defend my position on
Yeah, I don't care if you respond a day later. I don't care.
something. And then in the following morning, recording a video and saying that I haven't responded and I'm weaseling out of responding.
Well, I didn't say exactly that. I'm just indicating there was no response. That's all I can say so far. So I don't think I made any big point out of it beyond saying there was no response. And there wasn't. It's just a fact.
In the video that we watched, if you zoom in on the post that you had, you can see you posted the question only 10 hours previously.
Right, and you had just responded to the other moron, the Ian Gosling kook, and called him a very good demo producer. The guy who can't figure out that he's supposed to put the weights above the marks and not below the marks. The guy who made a fundamental error in the experiment and then obnoxiously said he proved something. Made bold claims on weak evidence. And you're endorsing essentially bold claims on thin and weak evidence.
I'm not just kind of staring on YouTube, waiting for you to respond or waiting for you to post something. Please note that I have other obligations.
Sorry. I'm sorry if I made too much of a point of I don't have a response yet, but I'm sure I just said there's no response yet. We'll see if he responds. And now you've done what I've requested, which is made a video, which is excellent. See, this takes a lot less time probably.
And I rank the needs of my family, friends, and the students for the courses that I teach far above responding to you.
Right. Again, that's what your physics has been doing for 350 years. So instead of doing science, you've just been preaching.
Especially when your responses show the kind of intellectual dishonesty.
So again, your intellectual dishonesty is to pretend you can't see that 200 isn't the same as 400. You can't see that can't possibly be conservation. 400 does not equal 200.
That I've been highlighting here. Now, despite all of this, I'm still planning on setting up the kind of lever demo that you're hoping to see. And again, in the end of the video that we were looking at, you do make some recommendations. I'm going to try to integrate those recommendations as best I can. And I do hope that you'll take part in the live stream that's going to be, again, on the morning of Saturday, July 29th. I think I might have accidentally said July 28th.
Yeah, it'd be great. And it'd be even better, though, if you had a live stream on all these subjects. Open it up to talking about photons and the bullshit of the double slit experiment that isn't really a double slit experiment. And, the Thomas Young did a single... he created a single slit pattern and called it a double slit experiment. All that kind of bullshit too. There's lots of subjects in physics that are just as catastrophically foul in terms of their unevidenced facts This whole idea of wave-particle duality, all this crap that you've just made up essentially because you say, we thought of everything and we can't think of another way to do it. Well, because you can't think of it, it can't be thought of, is basically the arrogance of physics. I mean, Feynman basically demonstrated that arrogance. He basically said, I'm really smart, and if I can't figure it out, you can't. I mean, that's the attitude of physics.
Before, but it should be Saturday, July 29th. So we can come up with an experimental setup that satisfies both of our criterion for accuracy. And after that, after we've both agreed that this experimental setup will work, then let's look at the results, whatever they are, and determine whose model they support. So again, I want to make sure that we all agree that this setup is reliable to within a close enough accuracy that we're going to be able to take those results as reliable. And not have you do the same thing of saying, I'm going to refuse any data that does not match my
So again, it's just a lie. It's not what I've done. I've explained why there's theoretical problems with your experiment. So it's just a lie to say, I'm just saying it doesn't show my results, therefore it's wrong. I'm explaining to you why it can't possibly make sense. 400 is not 200. That's what I want you to explain. You explain to me why I should believe 200 equals 400 and momentum was conserved. Fine, if you can do that. But I don't think there's a chance in fairyland, okay, that you're ever going to do that, okay? It's not going to happen. That gremlin is not going to fly.
Existing thoughts, because again, that is just concentrated confirmation bias. Okay. Until then, my previous position stands. If I'm not going to be interested in responding to the exact same things that you've been saying, again, you've said that you've said the same thing 4 or 5 times.
Right, now I'm just going to say it every fucking day. All right, so if that's what you want, if you're not going to respond to it, I'm going to say it every fucking day. Every fucking day I'm going to say, look, this physicist, this typical physicist, I make a simple point. 2 does not equal 4, and he won't respond to it.
Whatever. Again, I'm still not interested. My responses are still the same as they were. So until you come up with something new.
So again, just like every other of his responses, completely unresponsive to the critical point made. That you can't say the spring's momentum, the energy in the spring was conserved if you're producing different amounts of force out. If you're producing different amounts out, you can't say you conserved what went in.
Try to actually do an experiment where you're measuring an actual physical...
No, so he keeps doing this. Why are you encouraging DIY bullshit? Why aren't you saying something like, well, I should talk to the other physicists and maybe we should encourage a foundation to actually fund fundamental science research instead of doing all this phantasmagorical silly crap like making neutrino detectors. Maybe we ought to set up a lever and do a simple kinematics experiment and actually prove one of our theories. Maybe we should show it taking 4 times more gas to go twice as fast. 4 times as more gas to go twice as fast. Maybe Brozo should write a song about it.
System and show a case where your model makes a prediction and my model makes a prediction, and those 2 predictions are different, and the experiment matches your model. Okay? That's what scientists...
Okay, so again, and I'm obligated to prove you're not, is the simple statement I'll make to you. You've had 350 years to shore up any of this crap, and you have an empty pool of evidence. Rubber duck, squeak, squeak.
Do. That's what honest interlocutors would do, saying, I'm not going to...
Okay, so again, just measure his honesty in making this statement that somebody else is required to do an experiment when he's had 350 years to bang something into a lever. 350 years to show a 5-ton train going 10 miles an hour beating the crap out of a 10-ton train going 5. Just wiping it off the soccer field, so to speak. Just obliterating it with its twice as much of its special scalar energy power. They don't have any of these experiments. None. Zero.
Just assume that my idea is true. I'm actually going to back it up with real data based in reality.
Oh, yeah. Okay. So we'll see. We'll see what you back it up with, okay? I'm just saying, look, I'm fairly confident, okay? I mean, on springs, I'm not too sure of. But levers? Oh, come on. Yeah, they conserve momentum.
Or you can accept the data that I've taken and try to see if there's some way that you can improve your model,
Okay, so no, what I'll accept is let the Ian Gosling asshole redo his experiment that he fucked up, and it's going to prove me right again. So why don't we just go with that? He said that was enough proof. So if it was proof enough for when he did it wrong, okay, then it should be really good proof when he does it right.
Other mechanism that could have come, but just saying I don't think the velocity's right because...
Oh, I didn't say it just for that reason. I pointed out I will not believe that 2 equals 4. That you can say you conserve the momentum when it's 2 and the other number is 4. That's not conserving the momentum. So I'm saying that's a preposterous statement by you. Okay, and until you account for where the momentum disappeared to, or why it didn't show up. I mean, we don't even know what the real momentum is, right? I mean, what's the real power of the spring? Is the power 2 or 1 or 5 or 7? Can I get any amount of energy I want out of the spring? That comment you have not responded to, both in me writing it in text. I mean, I went to the trouble to write it, and you didn't respond, and you haven't still responded to it.
It doesn't match my model. That is intellectually dishonest. So
again, so that's not the critique. The critique is it doesn't fit conventional physics' theory regarding conservation of momentum. So again, you want to say you prove springs don't conserve momentum. Okay, that's a pretty substantial proof then. Okay, you proved it. We don't need to talk about conservation of momentum anymore because something as elemental as a spring doesn't conserve it. So we can just dispose of this law of conservation of momentum. It can just, who cares? If it doesn't work for a spring and it doesn't work for a lever, then why the fuck would we ever talk about conservation of momentum? It's a meaningless subject. Meaningless.
That's it for this one. I'm really hoping that I'm not intending to post this as a public video. I honestly hope that this doesn't get many more views than just, having...
Yeah, it's going to get plenty of my views, okay, and it's going to keep on, okay? You've engaged the conversation now. You've made the accusation against me that I have somehow done something inappropriate or wrong. And so, yeah, I'm going to fight back for my integrity. I haven't done anything wrong. All I've stated is your physics doesn't have shit for evidence. And then you're saying your shitty little experiment proves something. And I'm saying it's impossible for it to have proven that because what it's proving is basically debunking conventional physics. You're debunking conventional physics in the video. You're saying conservation of momentum isn't a real thing. And you don't have the cojones to say it plainly. Sorry, but I mean, it's just ballless of you to say it conserves the momentum when clearly 200 is not conserving 400 and 400 is not conserving 200. It's just absolute intellectual dishonesty to say that represents conservation of momentum. 400 momentum, same as 200 momentum. They're the same thing. We conserved it. No, you didn't.
DraftScience have a look at it. Because again, I want my channel to be focused more on how do we do scientific...
And that's all fine. You can do whatever you want with your channel, blah, 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 and all that crap. I'm really not trying to distract you from that. I want a little tiny percentage of your time to actually address real questions. You're claiming they're not real questions. You're claiming they're not valid accusations. I think they are. And I have tried to pay people to answer them, and they won't take my money. All right, and they won't do anything publicly because, frankly, they're afraid of the argument, frankly. Because most physicists don't know the origins of mv squared. They don't know the real history. They don't know that Leibniz was quoted as stating Descartes was too much of an atheist. He was spreading atheism. I mean, he was a Jesuit, for fuck's sake. You know, I mean, it's just... Descartes was tutored by a Leibnizian. I mean, there was only about 5 of them on Earth. That's who tutored her. Shit.
The critical thinking, actually showing examples of experiments and how we can develop those experiments, analyze.
Look, that's already on the table. There's all kinds of bozos doing all kinds of shitty experiments. So you're saying that this is good, okay? We got 3 people doing experiments. Ian Gosling, who you say does very good demos, all right, who just made such an egregious error. It was an insanely stupid error. All right, then we got this bar guy. Dropping batteries and, the crappiest carts in the universe and blah, 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 blah. And then we got Brozo, who doesn't care what angular momentum is. Angular momentum, smangular momentum. Doesn't care about a quick release. Who cares? Sloppiest, dirtiest experiments you wanted to see. With a bunch of porn images on top of them. I mean, really. You're going to have to do better than this. This claim that we have to prove you wrong when you don't have to prove you right. I mean, it really is. It really is shitty. You show up at court with a picture of a gun, and then you force me to prove that the picture isn't a picture of an actual gun that's actually in his house or something like that. No, I don't have to do all that crap. I have to say, bring the gun into court and show me the gun.
Take real data and analyze the results of those experiments and compare it with models. Those are the sorts of things that I want my channel to be more focused on.
Well, when your channel, when you do the lever experiment, you're going to be in trouble, frankly, I think. It's gonna cause you some real problems because it's not going to show kinetic energy winning.
Not having a, back and forth argument where we are not finding common methods to reach reasonable conclusions. So that's it for today. Hope everyone's doing well.
Okay, so I appreciate the response, but frankly, that's the personality problem we have. Frankly, I made a valid criticism. You don't think it's valid, you dismissed it. You didn't address it at all conceptually. I mean, I drew it, I tried to explain it as weight, I tried to explain it so many different ways that I can't make 200 momentum and then 400 momentum, no matter how I configure it, no matter how light I go or how heavy I go. I can't make 200 momentum and 400 momentum move this spring the same amount. I can't do that. Physics can't do that. And your experiment says you can. And that's the problem with it. So you have to explain how it is possible that I can make 400 weigh 200. The spring will somehow say it's the same amount. You started with the same amount in the spring. You got different amounts out. If you put those amounts back in, you're not going to get the same compression in the spring. It shows there's a leak somewhere. You have to explain the leak. It's a closed system. Where is the momentum leaking out? All right. So yeah, it's unfortunate we have this problem. I don't know really how to get around it. If you're going to keep calling me intellectually dishonest because I point out how there's flaws in your experiment, that there's parts of it not consistent with logic and reasoning or other experimental facts like Hooke's law, I'm going to call bullshit on that. I mean, it's a perfectly valid critique. Your experiment has flaws. It's like Professor Lewin's experiment. There's 2 carts. and I drew them over and over again. I'll do it just for you. Well, you're probably not watching this far from. I wouldn't be, right? That's like 2.5 hours. Well, you could do it on your vacation or something. Someday you could get around to finishing the video. Let's just say that someday you get around to it. Out of just curiosity.